Hello everyone and welcome back to another statistics video. In this video we are going to talk about the binomial probability distribution. And this is actually a special case of the discrete random variables. So let's get started. With a binomial probability distribution, we've got four criteria that has to be met. The first one is that the experiment that's being performed has to have a fixed number of trials, which means we're going to have a set number of times that we're going to repeat it or it's going to happen. We cannot go on an infinite amount of time. The trials have to be independent, which means the outcome of one does not affect the outcome of the other. And there are only two possible outcomes, and they have to be mutually exclusive. And we call these outcomes either a success or a failure. And then the probability of a success is going to be the same for each trial. So what's the notation we're going to see here? Well, n is going to represent the number of trials. P is your probability of success. The probability of a failure is the complement, which would be 1 minus p. And then x is going to represent the number of successes out of the n trials. So suppose we were flipping a coin and we were doing it 10 times. Then that means we're only looking at numbers between 0 and 10. Okay, and what that means is we could see probabilities associated with flipping at 1 time or flipping at 8 times, but we wouldn't see 11 in that. Why? Because we're only flipping at 10. We can't have 11, a probability of flipping at 11 if we're only going to go up to 10 times. Let's talk about the mean and standard deviation. The mean is n times p. The standard deviation is the square root of n times p times the complement 1 minus p. So this is going to be a little bit easier to compute than it was for the discrete distribution. So let's look at a few examples. And we are going to use our SALT technology to be able to figure out these probabilities. So let's say we are conducting 10 trials, probability of success is 0.4, and we want exactly 3. We're going to go to SALT, we're going to type in 10, the probability of success is 0.4, and we want exactly 3. And if we go up here, we've got some options. We're going to choose the equal to option, and my answer is going to be 0.21499. We got number 2, and it's going to be 50. So our number of trials has increased, and look at that probability of success. We're looking at 0.99, so almost 100% there. And we want to know what's the probability we're going to have exactly 38 successes. And you can see that probability is going to be less than, it'd be almost 0.00001. I'll say approximately 0. 3, we're looking at n is equal to 10, probability of success is 0.65, and x is less than 5. So we got to think about what that means in this context. So here's 0, 1, 2, 3, 4, and 5. We are talking about discrete values, so we're talking about whole numbers. So if I'm going to be less than 5, it could happen 4, or 3, or 2, or 1, or 0. So that's actually the same thing as asking the probability of being less than or equal to 4. And to use SALT, those are really our only options. Notice that equal to there, we can't change that. So we have 10 trials, probability of success is 0.65. And we are going to look at less than or equal to 4. We're going to get 0.09493. And then the last one, we want the probability that we are greater than or equal to 12. Probability x is greater than or equal to 12. Using our technology over here. we're changing it to 20 trials. The probability of success is 0.7. And we want what's going on the right-hand side. And notice that flip that inequality there. Greater than or equal to 12. 0.88667. So let's look at a few examples where we're going to find the mean and the standard deviation. So remember our formulas. The mean is n times p. The standard deviation is the square root of n times p times 1 minus p. So the mean for the first one would be 10 times 0.4. And 10 times 0.4 is 4. And the standard deviation would be the square root of n times p times 1 minus p. 1 minus 0.4 is going to be 0.6. And I'm just going to type that in the calculator just like that. Square root of 10 times 0.4 times 0.6. And I get about 1.549. I'll go 3 decimal places there. So let's do one more of those. So we want to look at that last one. So the mean is n times p, and that's going to give me a 1.4. The standard deviation is the square root of n times p times 1 minus p. And 1 minus p in this case is going to be 0.3. In my calculator, I'm going to type in 20 times 0.7 times 0.3, and then I'm going to take the square root. I got 2.049 for that. So let's look at a word problem. And we're looking at on-time flights. American Airlines flights from Dallas to Chicago are on time 80% of the time. So there's your probability of a success. Suppose that 15 flights are randomly selected. We want to find the number of on-time flights that's recorded. A is asking us to explain why this is binomial. Well, we're looking at a fixed number of trials. We have trials that are independent. Okay, so the outcome of one flight is not going to affect what happens on the outcome of the other ones. There's only 2 possibilities. You're either on time or you're not. And the probability of success is the same in every trial. And that probability of success is 80%, or we would say 0.8. B is asking us to find the probability of exactly 10 flights that's on time. So the probability of 10, we can go to our technology here. We need this to be 10. Probability of success is 80. And we are looking for exactly 10. We see that probability is 0.10737. So this is what we would expect to happen in the long run. If we were to repeat this experiment over and over and over again, we would see that probability of success being this, and we were to repeat this over for groups of 15 is what that n means. Then we would expect on average for exactly 10 flights to be on time. That would happen almost 11% of the time. So that's what, 10.737%. C, find the probability that we are looking at fewer than 10 flights. So that's the same thing as the probability that x is less than or equal to 9. So I'm going to go to solve. Less than or equal to 9. So looking at that left tail. Okay, notice the less than there. Less than or equal to 9. And I got So we've got 15.8, and we want less than or equal to none. I get 0.06105. 0.06105. And then D is asking us at least 10. So at least is greater than or equal to 10. Greater than or equal to is the right tail. And I'm going to get 0.93895. So that would be the percentage in the long run, about almost 94% there. And then E is asking us to find the probability that between 8 and 10 inclusive. So that's the equal to, including the equal to and the 8 and 10. So I'm going to use the between. So I want greater than 8, but less than 10. And I'm going to get 0.15999. Let's double check that part B, that first one, because I had my N incorrect just a second ago and I had to fix it. So we want the probability of equal to 10 in part B. Now get 0.10318. Yeah, so I must have had that wrong earlier. Sorry about that. 0.10318. 0.10318 for that probability. So when you're doing these, be careful. I had accidentally the wrong number here for part B, and then I fixed it for the other parts. So that's how we use SALT to answer our question.